Hello everyone. Today we're going to elaborate on some factors affecting the customer satisfaction, and the main method we're going to use is hypothesis testing. So let's turn to problem 1. Now a market analyst wants to know better about customer satisfaction ratings, and he gathered a sample of 10 wireless mouse models from ScopeTech, and at 5% significance level, he wonders if there exists a positive correlation between the price and the average rating. Now all of the data here is real life data, and you could just go to the scopetech.com.au to search for the name of each of the products here. Now, since we're working with a correlation test and we're working if it's positive or not, which means it's a one-tailed test. So basically we're going to do the one-tailed Pearson correlation test. We have our null hypothesis is p less than or equal to 0, which indicates a negative or no correlation between the price and the ratings. And the alternative hypothesis is p greater than 0, indicating a positive correlation. Now we have the R value, which is the correlation coefficient. We actually have a formula to calculate this, but personally for me, I'm going to just use Excel function to execute that for me. It's a way more time saving, and the eventual result is 0.636, and since a sample of 10 products is gathered, the observation value n is equal to 10. And now we calculate the t-statistic value. The formula for it is r multiplied by n minus 2, all divided by square root of this is square root of n minus 2, and all divided by square root of 1 minus r by to the power of 2. We plug the real data in, and the eventual value is 2.331. Now we're working with two subjects, which is the price and the average rating. So our degree of freedom should be observation value n minus 2, which is 8. And let's go find the t-critical value. At 95% and the degree of freedom of 8, one-tailed test, we should refer to this t-table, but our critical value should be one-tailed 0.05. Let's go to it. It should be 1,860. So here's our t-critical value. Now, since the t-statistic value is greater than the t-critical, we reject the null hypothesis, and we conclude that there is a positive correlation between the price and the ratings. Let's turn to problem 2. Oh, sorry, here is some graphical display for you to better understand the test. You can see here is a scatter plot with the trend line. It goes upward, indicating a positive correlation, and we have 40.5% of the variation can be explained by the price, as the R square value, the R square value here is 0.405. And for the bell curve distribution, we can see that our t statistic value here, it falls into the rejection region, hence the rejection for the null hypothesis. Let's turn to problem 2. An immersed consultant wants to test whether the shipping speed would affect the customer satisfaction. Now, there's a sample of 20 power banks were taken using the Shopee e-market. We can have the link here, you can just visit it later. And 10 with delivery estimated within 2 to 3 days, which is basically fast delivery time, and the other are slow, indicating by 4 to 5 days. Now, at a 5% confidence level, is there enough evidence to conclude that customers prefer faster shipping products? So let's turn to the test. We have 2 samples we're working on, the fast and slow, which is why we're using the 2 sample independent t-test, or 1 till 2 sample t-test. They're just the same. And we have our null hypothesis here, which is the new fast is equal to the new slow, and the alternative hypothesis, which is the new fast is greater than new slow. Now we have a table showing the mean of the 2 groups and the observation. We can see that for each group we have 10 samples, hence the equal observation value. But in here, the mean for the fast delivery estimated time is 4.83, and for the 4 to 5 days group is 4.55. To calculate this value is pretty easy. You just need to sum all of this up and divide to the observation value, which is 10. We got these. And let's go find the t statistic value. So we have the formula here. The mean of the group 1 minus the mean of the group 2, all divided by the square root of the variance of group 1 divided by the observation of group 1 plus the variance of group 2 divided by the observation of group 2. There's actually a formula to calculate these variances, which is here. And one more time again, I prefer the Excel function way. I mean, we can do this, but it would require a lot of time. We have to gather, we have to find the mean, and then we have to minus all of the subject, etc. It's not worth it. So we plug the data in the formula, and we got the eventual result, which is 1.698. And let's go find the degree of freedom for this value. Oh, sorry. Here's the formula for the degree of freedom. I plug the data in, and the eventual result should be roughly rounded to 13. Now let's go with the t-table with 95 with the alpha equal to 0.05 and 1 tail test with the degree of freedom of 13. Let's see, 0.05, 1 tail, degree of freedom 13, it should be 1.771. So our t critical value is 1.771. And since the t statistic value is not greater than the t critical value, we fail to reject the null hypothesis, and we conclude that there is no evidence to support that the shipping time would leading to better rating based on this sample actually. And let's turn to problem 3. Oh, here's the bell curve distribution for you, and you see here that our t statistic value, it does not fall to this rejection region, so we cannot reject the null hypothesis. Now let's go with problem 3. A product researcher they want to see if the branded products are having better rating than the unbranded one at the 5% significance level. Once again, all the data is reward data, and you can find it on Shopee eMarket. Now, let's get to the test. Once more time, we're working with the two samples, the branded and the unbranded one. And since it's one tail, we're going to do the one tail two sample t-test. We have our null hypothesis here is the nu of the 1 is equal to the nu 2, and the alternative is nu 1 is greater than nu 2. I'm using the same method at what we've been doing. We got this table. So the mean of the branded is 4.9, followed by the 4.06 of the unbranded. We got both two groups having the 5 sampled altogether, and the variance after plugging in the data into the formula, we got the eventual results, which is 0.005 and 0.368. Now we go to the t statistic. So the formula is the same as the previous one, and we plug the data in. We got the eventual result at 3.075. We have one tail test at 95% CI, and we have to do the degree of freedom as well. It's actually equal to 4. It's actually, we roughly round it up to 4. It's not always a rounded 4. But yeah, the t critical value for that should be around here. One tail 0.05 and degree of freedom of 4, it should be 2.132. So here's our t critical value, and we can clearly see here is our t statistic value is greater than the t critical. So we reject the null hypothesis, and we have evidence that the branded products have higher ratings than unbranded ones. So after the 3 problems we can see here, it's not the overall picture. It does not grant us the overall picture, but we can see that the customer, the e-customer, they're trying to make out the best value of their money. So like, for the problem 1, we can see that they actually are willing to invest on the products with higher rates, with the higher price in return for better quality. They're willing to invest on that. And in this problem 3, the ratings on the branded is actually greater than the unbranded one. So basically the customer, they want to spend the money on real good product, even if it's a higher price, which indicates might be better quality and from well-known brand. However, it's quite it is quite vague is for the problem 2, the shipping time does not affect the rating. I think it might because of the sample we gather or because of many other factors, but yeah, it is our customers' main priorities is the quality of the product that they invest the money on. Thank you.